Hey guys, it's Vashi, and today we're going to be looking at Chapter 10, Section 1, Inverse Variation. So, an inverse variation is a relationship that can be written in the form y equals k over x, where k is a non-zero constant and x cannot equal 0. So k is a constant, which means it never changes. So by multiplying each side of this equation by x, you can get x times y is equal to k. So for any inverse variation, the product of x and y is a non-zero constant, because x can't equal 0. So say if you took this equation, y equals 3, which is k, the constant, over x, and then you multiply both sides by x, and you get xy equals 3. So that means y varies inversely as x, and y is inversely proportional to x. So now let's look in example 1, identifying an inverse variation. Tell whether each relationship is an inverse variation. So say if you took a graph or like a table like this. This was x, this is y. And there's 3 boxes, and you get 1, 2, 4, 20, 10, 5. So how do you find out whether this is an inverse variation or not? So one way you can do it is that you can write a function rule. So say what you want to do is find, if you multiply x by something, you should get 20. So 1 times 20 equals y. So you can also write that as graph paper. Okay, so first of all, you get an equation like this: k equals x, y, and they tell us y equals 2, so 2 times x equals 4, so 4 equals k. 2 times 4 equals 8, 8 equals k. Now you want to write a function rule. So y is equal to 8, which is k, the constant, over x. You always want to write the function rule in y equals k over x form. So next you want to make a table of values. So x, y, or x and y, yeah. So x is -4. Plug that into that, and you get -2. Then you put -2 in here. So -2, and you would get -4. Then you have -1, and you would get -8, 1, 8, 2, 4, 4, 2. So now you would graph all that because you have now all your coordinate pairs. So you just have to graph it now. So you make your graph. So -4. So 1, then 8. In that case, it'd be all the way up here. And then, so then 2 and 4. And then 4 and 2, so. So then and these lines keep on going and going and going, but they never touch this one line called an asymptote. So you'll learn about asymptotes later in a different chapter or lesson. So then that's your graph. See, it matches the shape, sort of like this one in the book. So that's how you graph an inverse variation. So now let's apply it to some real world problems. So here's an example from the book. The inverse variation xy equals 2,400 relates to the vibration frequency y in hertz HC to the length x in centimeters of a guitar string. Determine a reasonable domain and range, and then graph this inverse variation. Step 1. Solve the function for y. So they give you x times y is equal to 2,400, right? So you got x, y is equal to 2,400. And now you divide both sides by x, so you get y equals 2,400 over x. Now you have y equals k over x. 2,400 is a constant, k. Then you have to decide on a reasonable domain and range, because they say that in the problem. So length is never negative, so x can't equal 0. I mean, anything less than 0 or 0. So you got x greater than 0. And because y and xy are both positive, y is also positive. So y is also greater than 0. So now you make a table of values. Make it vertical this time. So first one, 20, because these are all big numbers, so you want to start big. 20, 40, 60, and 120. So you need these two. So for 20, if you plug that into this equation right here, you're gonna get 120. Then if you plug 40 in, you're gonna get 60. And 60 is gonna be 40. And 120 is gonna have to be 20. So you have your XY intercepts now, or coordinates, and now you're gonna graph them. So you're gonna want to use like some big increments on this graph because values are pretty big. So say like 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120. Because that's the most like biggest number. So, and then same here. It'll just continue up, mostly higher than that. So I want to extend that. You can't really extend it down there because that's the end of the page. So we're gonna have to improvise. So now, So now you gotta graph this. So you have 20 and then 120. So 20, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. It's up here. All the way up there. And then 40, 60. So 40, 1, 2, 20, 30, 40, 50, 60. So right here. And then 60, 40, so right here, a line that looks like that, and then 120, 20, like right here. So your graph's gonna look like that, and since it can't be positive or negative, it doesn't go into this area. So we really didn't need this. Animate it. So, yeah. So now let's learn something called the product rule.